Salut à tous, on espère que vous allez bien. On se retrouve pour le 8e épisode de Crack the Data avec Andreea, qui est Data Scientist chez Devoteam, également enseignante chez Jedha. Elle va nous parler aujourd'hui de gestion de projet machine learning. Donc, quelles sont les grandes étapes pour mener un tel projet? Qui sont les parties prenantes? Quelles sont les bonnes pratiques aussi? Vous allez pouvoir retrouver toutes ces ressources et bien d'autres sur notre plateforme d'apprentissage Julie. Le lien est juste en dessous dans la description. N'hésitez pas à la rejoindre. On vous souhaite en attendant un très bon apprentissage et un bon visionnage. À bientôt.
Hello everyone! Today we are going to approach a very interesting subject from my point of view, and this is working on machine learning projects. So here we go. This video's objectives are learning some project theory basics such as classification of projects, life cycle, possible failures, understanding project management concepts, roles, processes and phases, approaching data science projects and how do they adapt to previous concepts with respect to life cycle, phases, tools, roles. Learning about the machine learning workflow on a specific project and about the concerned parties is another objective of this video. We will continue with a case study on working on a machine learning project from project ideation and organization around resources and tools up to project execution phase. And at the end, I will finish with some conclusions and advices. So let's start. How do we approach projects in general? A project is a problem scheduled for solution. According to the project management body of knowledge, a project is defined as a temporary endeavor with a beginning and an end, and it must be used to create a unique product, service, or result. The key concept here is the solution, which is a product, service, or result with specific performance requirements that must be met. Steps taken to accomplish routine activities cannot be thus considered projects, such as service provisioning, hardware and network refreshes and increasing capacity, the majority of software or technology updates, application and operating system patch release updates, database reorganizations, for example, security updates, business process re-engineering that changes process but not technology. From this perspective, we can observe some common project characteristics all around businesses. They are unique in nature and adapted to fulfill clear objectives or goals, require a set of resources ideally defined at the beginning of the ideation phase. They have a specific time frame for completion with a definite start and finish, because once the goal is achieved, the organization created for it is disbanded, or sometimes it is reconstituted to begin work on a new goal or project. So the delivery is time crucial for the business from a project perspective manner. Projects also involve risk and uncertainty. Seldom does a project conform to the desired definition. Often a project encompasses a new technology, and for the organization, these bring into play significant elements of uncertainty and risk. Projects also require cross-functional teams and interdisciplinary approaches. The project needs to draw from the skills and the talents of multiple professions and sometimes even from the other organizations. The complexity of advanced technology often leads to additional project difficulties as they create task interdependencies that may introduce new and perhaps unique problems. Projects also have limited budgets, specific costs, and performance requirements. So, a project is successful when it meets, of course, its expectations. Depending on the type of the project and its specific context, there are many ways to classify a project, such as by size, cost, duration, team, business value, number of departments affected are some attributes of this concept. By type, new or maintenance, upgrade, strategic, tactical or operational projects. By application, such as software development, new product development, equipment installation, and so on. And finally, by complexity, risk and uncertainty. The literature classifies projects by taking into consideration specific areas, internal to the company's strategy that initiates the project, or external to the company's strategy but applied to industry, geography, or international contexts that surround the project's goal. Furthermore, if we go deeper on the industry-focused projects, we can observe that sometimes there will be a sort of IT component to be taken into consideration while initiating new projects, whether they are at a developmental stage or in a re-engineering phase. This is where data science and machine learning projects can be found, and although all projects in all sectors have their challenges, there are some unique considerations for IT projects. Within an IT project, there are different stakeholders such as hardware, taking into consideration operating systems and platforms, networking such as firewalls and connectivity, software such as applications and interfaces, business intelligence that cover big data, data warehousing and analytics, service management, contracts and procurement, dealing with vendors, etc., service desk and field engineers, information security from a governance perspective, compliance and data management aspects, etc. So, you can observe that some of these areas may impact directly the complexity of a data science project in a business context. In plus, there are a lot of communication requirements between technical and business parties, testing and prototyping aspects, transition to go live or in production, which is the ultimate stage before validating that the goals of the projects have been met. Having said that, we arrive to the project lifecycle in standard projects that may apply also to IT projects. The initiation phase is the first phase of a project and is the beginning of it. The planning phase concerns organizing and preparing everything that surrounds this specific project. The execution and the implementation phase are carrying out the project, and the termination phase is closing the project and receiving feedbacks and next steps. At the completion of the project, given the time and the level of activity, the cost and staffing would project in volume these two particular curves. So you observe that at the lifespan of a project, including different phases I have talked about earlier, there are a lot of costs and staffing aspects to be taken into consideration, which increase at an execution level. With respect to the level of risk and cost of changes, we can also observe an intersection, and it is ideal for these two lines you observe here to meet as low as possible somewhere during the execution phase of the project when the goals are clear and the implementation methods established. You may laugh at this meme, but it was very revealing for me. The last consideration on the project theory will be the failure of certain projects. In fact, of the most part of them, according to studies. So, the American Management Association states, for example, that only about 17% of all software projects done in the United States meet the original targets. 50% must have the targets changed, meaning they are usually late or overspent and must have their performance requirements reduced, and the remaining 33% are actually cancelled. If we get broader in project failure analysis, because there is a field that studies that, everyone agrees that failure rate is too high, meaning that 70% of the projects are late and that 80% of the overall projects do not fulfill all the expected requirements. There are a lot of common reasons of IT project failures, and some of them, put together by Wolf Erickson from RIG tests, are the following: lack of proper planning, failure to manage scope, cost-cutting approaches, overly optimistic project schedule, poor selection of technologies, overstaffing of projects and poor communication, data migration by unskilled resources, little testing, or even skipping the testing phase. He emphasizes on the fact that lack of proper planning and failure to manage are important aspects that determine project failure because of unclear scopes and objectives, confusion about roles and responsibilities, inefficient utilization of resources, unavailability of resources at critical time, uneven workload on the team, incorrect time estimates and cost estimates, poor performance. He adds that the projects fail when project managers are not able to make decisions, not able to manage scope, schedule, budget, or risks. The decision is not made adequately to business strategy behind it. The managers are not able to track project progress or to measure performance or even to communicate effectively. So you can observe why understanding some basic project management concepts as a data scientist is so useful. Let's go deeper now into project management concepts. Now that you know the basic theory around projects, you will observe that its main characteristics can be found within the definition of the association of project management, meaning that the project management is the domain and the application of processes, methods, skills, knowledge, and experience to achieve specific project objectives according to the project acceptance criteria within agreed parameters. In plus, the association states that the key factor which distinguishes project management from just management is that it has this final deliverable and the finite time span, unlike management, which is an ongoing process forever and ever. Because of this, a project professional needs a wide range of skills, often technical skills and certainly people management skills and good business awareness. So you can understand why I am approaching this subject within a data science context, and it is because I wish I also had this knowledge when I first entered into the working field as a beginner. Perhaps managing projects, it's not your first priority as an aspiring experienced data scientist. Nevertheless, understanding the concept, the aim and the limitations of being part of different projects is a very big advantage for you. In the project management body of knowledge, managing a project includes a broad area of skills for identifying the business issues and risks, clarifying or identifying requirements, establishing clear and achievable objectives, balancing competing demands for quality, scope, resources, time, and cost, adapting to different concerns and expectations. These skills are promoted by individuals that have project management roles, and Alexandra Cote has compiled a list of must-have skills for being a successful project manager, such as solid understanding of business cases and risk management processes, strong leadership skills, ability to monitor and control budgets, good communication and negotiation, capability to make decisions under pressure, strong interpersonal skills necessary to lead a team, ability to interpret instructions regardless of their form, strong organizational and multitasking skills. In addition to this, a project manager officer needs to also have analytical skills, accuracy and attention to detail, excellent time management skills, capacity to maintain schedules and meet deadlines, problem-solving skills, accountability, work ethic, working knowledge of project management tools, and the list goes on. As you can observe, interpersonal skills, time management skills, organizational, multitasking, decision-making skills are crucial for being a good project manager. That's why having a good understanding of the phases of project management is so important. There are mainly 5 important stages through which a project needs to pass, such as I explained earlier. But here we are going to focus on the management aspects as well as the roles involved. Notice that these aspects are characteristic to each company in part and that they may vary depending on the company's strategy and internal protocols, the complexity of the project, the budget, the resources allocated, the time frame, etc. The Association of Project Management defines in more detail these 5 steps or phases, but what you need to keep in mind is the following. The initiation phase ensures that the project will stay on track and which are the means of achieving its scope. The planning phase includes details about how the project works and how it will be carried out, how it will be monitored and controlled, how communication will be facilitated, and information about costs and timescales will be accepted, taken into consideration, and fulfilled. The execution phase is the most complex stage, and this is normally where you as a data scientist or a machine learning engineer will be involved the most. The closure is the last phase, and it will review the output of the project, and it will give further feedback on the successes and the mistakes made during the project development and lifespan. And lastly, you can observe the roles of each party involved with respect to project staffing normally happening at the end of the project planning phase. Of course, all of these concepts apply completely in an ideal situation or context. It may be possible that depending on different factors such as the maturity of the project, its complexity, and even your experience in the field as a data scientist, you will be involved in more or less stages, and not only as a developer, statistician, econometrist, analyst, data engineer, or machine learning engineer. Having seen all this theory, we are now going deeper on the data science project approach. The Team Data Science process lifecycle promoted by Google is composed of 5 major stages that are executed iteratively and that I find very self-explanatory. These stages include business understanding, data acquisition and understanding, modeling, deployment, and customer acceptance. You don't need to learn them by heart, it is just important to know that they are there somewhere and that you can make use of when in need. In other words, a data science project follows the same phases that a normal project needs to follow, but adapting it to contexts where the objective is to make good use of a great amount of information that can be found within different databases. It is very important for you to keep in mind the previous patterns seen in the life cycle of a data science project and this particular slides that approaches in more detail these steps. Normally, it is pretty intuitive, especially since you are following these same steps while working on a particular dataset from the beginning with collecting the necessary data up to the end when you arrive at the results and you make sense of your work by explaining it in hopefully a comprehensible manner to people not having the same level of technical skills as you do. Of course, while working on a specific data science project, you will need to exchange information and share work with your colleagues who will have similar or different roles as yours. These roles have sometimes overlapping responsibilities, especially if the project's budget cannot accommodate multiple resources. You may find yourself at a certain point working on multiple areas, and this is why it is very difficult sometimes to define roles in the data science field. In addition to these roles you see here, within a data science project you may also find project managers, solution architects, database administrators, data and analytics managers, business analysts. The main idea that I would like you to suggest is that every data science project needs to have a data translator who understands the data and the business meaning behind it, the data manager who will make sure that the data is secure, reliable, well organized and proper, A data scientist who will have a global view on the processes found within the databases and the possible modeling behind them, with a great amount of force proposition and technical information vulgarization. And finally, the machine learning engineer who can be in charge with optimizing solutions for performance and scalability, implementing custom machine learning code, deploying machine learning solutions into production. So a machine learning engineer might appear at a certain point of a project depending on its volume and complexity. But it's not always the case. A data scientist will do this work with approaching perhaps less complex models. So having said that, let's direct ourselves to the technical landscape describing data science domains. Nowadays, there are a lot of tools that can be used for data science and machine learning purposes. It will be impossible for you to master all of them, and it is not even necessary. Usually, the concepts behind these tools and platforms are the same, and you need to know how to use one type of function for you to be able to apply it into a new interface. If you watch this graph of the Data Science 2020 landscape, you are going to see that there are multiple platforms that can be used within the analytics field. So there are platforms that cover subjects for many data science subcategories, such as data analysis, data science, business intelligence, visualization, machine learning, computer vision, artificial intelligence, speech and natural language processing. Having to work on one or more of these platforms depends on the company's strategy, partnership, eagerness to invest, infrastructure, so on and so forth. Normally, if you do not have a license, you will accumulate experience on open source platforms. This is why it is within your company that you are going to be able to put at the maximum potential into practice your analytical skills. And these platforms that you will do that on are usually paying platforms. There are also a lot of free of charge open source platforms that you can use, as you may already know, but with obvious disadvantages such as high learning curves, compatibility issues, liabilities and warranties, security, hidden costs, difficulty to automate and to put in production fluently your projects, etc. So, how do we actually approach machine learning projects? Obviously, there are a lot of common points between traditional software and machine learning projects. But whereas traditional software is a transparent field based on the accumulated experience of over 30 years with imperative applications for company function, machine learning can be sometimes a minefield with a lot of questions yet to be answered too. Amazon Web Services states that 86% of data science decision makers across the Global 2000 believe machine learning impacts their industries today, but that unfortunately investments made in machine learning projects are questioned and projects are abandoned when the implementation does not match the vision. In addition to this, machine learning projects have some aspects that frequently make them different from traditional software engineering projects, such as whether the machine learning project is currently in a research or in a developmental stage, what are the economic values of the machine learning project and how are they expected to be beneficial to the company, how to verify that machine learning assumptions are valid, for example. So these are important aspects to be taken into consideration, and people that are not from a data science field have difficulty sometimes to see the end of the route. As a machine learning engineer, it is not always up to you to take into consideration these surrounding circumstances of all the project phases, but I consider that this information is at least useful because it is always good to know more than less. and knowing the possible difficulties that may occur can help you and your team to surpass them easier. So we can extrapolate all this situation, such as implementing machine learning projects, to cooking. You begin with an input, you prepare your field of action and your instruments, so everything is set up when you need to apply different techniques in order to create the greatest output that you are going to safely store for consumption. Even though the machine learning modelization is not more than coding and interpreting in a structured manner, an engineer or a data scientist makes it smart through training with data, and this is a very important characteristic. So the quality of your input is going to affect substantially the result. It is just like a very well prepared food that uses expired products. Do you think that the taste is going to be the best, or that you will not get sick after eating or investing it? It's up to you to decide. So keep in mind that the first phase of a machine learning project, after having been validated at the business case level, is gathering the data and preprocessing it, which will consume somewhere around 80% of your time and energy. Researching the models that will be the best for the type of data you are going to use and that is the most suited to the project's goal is the next phase. Implementing the model, training and testing it, follows logically in your machine learning workflow, and the last step, the evaluation, interpretation and the revising of your models are the goals and the results of a machine learning project. With respect to roles on a machine learning project, James Kotecki wrote a very interesting article on medium.com which explains the importance of considering the parties involved in a project, which is a technical process but which starts and ends with people. He explains that data scientists are the X factor in a machine learning project, representing the main difference between a machine learning project and other kinds of software development. What I really liked in his approach is that he structures via pie charts project roles during different project phases, finishing with leadership roles, but always surrounded by the project management guidance and supervision. So we can split projects in three main phases. Data preprocessing phase, which consists of data engineers wrangling the data, while the data scientists offer guidance and do data engineering as needed. Algorithm development phase is another important step, where data scientists create algorithms while software engineers offer help and guidance. And solution deployment phase, being the last one, is the phase where software engineers implement the solution while data scientists tweak algorithms as needed. Having presented all of this, let me give you an actual example of a data science project from one of my experiences, without many technical details, but with the aim of following some of the concepts concerning project management, data science lifecycle, roles, and tools. All the companies have some data to take care of. The bigger the company, the more human resources, the more clients, the more products and services to be logged in and followed up. And this is without even taking into consideration the core job of the company that could provide further on data enhancement for its clients. For one of the projects that I was working on at the time, data was stored into an internal data lake, and most of it was related to customer information, IT assets, hardware and software, and activity recording. This data was, of course, not processed entirely, and the management wanted to make use of it by trying to fight against digital waste and with the aim of reaching higher energy optimization levels of its industrial park. So here was the first ideation of the project, discovering data science and machine learning needs at the business level while taking into consideration the actual business context. Digital waste in this specific situation was related to human resources that were having work computers preset with all the applications that the company paid for and who were not using them at their full potential, either because the applications were not related to their job roles, either because they were once useful for a handful of people but licensed for every employee and now obsolete. So the licensing continued for the entire company in a wasteful manner. The objective of this internal project was clear now: considering adequate solutions by creating the conditions for the development of predictive data science bricks, considering and identifying the user's roles and frequency of app utilization, and profiling and predicting behavior to bring significant additional value through the generation of data likely to bring up functionality and functional relevant profiles. So now that the business need was identified, the recommended solutions and the feasibility studies were carried out and the business case approved, the initiation of the project started setting up the stages for the quality planning of the project. The tasks and the resource requirements, the time frame, the budget and the risks were identified further on, and the project was prepared to step into the most important phase, the execution, meaning allocating the resources necessary, the infrastructure, the teamwork management, while constantly working towards and focusing on deliverables. This was the stage where I came as a data scientist. The technology that I was going to use was already put into place, and you may have an idea now that the tools that I was going to use were found among those that enrich the data science landscape previously mentioned. Nevertheless, having a good understanding of the business needs helped me a lot into approaching the data. The subject that I was going to work on concerned user profiling and predictive analysis, something that every data scientist would like to begin with. I will not go into a lot of details, but the work was complex and it included a lot of open source data as well, in order to be able to predict customer support and intervention while accounting for traffic and weather conditions. So the project was complex, it was very interesting, and I gained a lot of experience afterwards. Before starting the execution phase of this particular project, there were benchmark initiatives with Databricks, RapidMiner, TIBCO, or SAS to see which is the most adapted tool to the project needs. Here is where I started to use Microsoft and Google Cloud for data storage, R and Dataiku for data preparation, R, Python, and Dataiku for machine learning modeling, training, testing, and deploying, Power BI and Dataiku for visual representation and improvement. On this project, in my team, there was a lead data scientist, there were 2 data scientists, among which I was one of them, a data architect, and a data analyst. We were collaborating all together, but since it was an internal project, initially at the POC and at the proof of concept level, each member of the team was working on overlapping domains, receiving the opportunity to learn more, not only on one zone area, but on the tactical and technical aspects of the entire life cycle of the project. I was unsure about my own technical abilities at the beginning, since I was less experienced than I am now, with less knowledge on programming and data science platforms. But I can really appreciate after all of this the importance of multitasking and passing through all the stages of a machine learning project. This helped me to have a wider view on how to deal with projects in general and how to work with colleagues having almost the same technical background as me. So my main responsibilities on these projects were to analyze the customer's needs follow the data acquisition, transformation, and enhancement processes, and compare them with the elements developed by the previous partner who was working on the project. Some other responsibilities were to transform and format the data on users, create user profiles and predictive analysis of their evolution, considering the rate of use of resources and applications. Another responsibility was to realize dashboards under Power BI to be used for the interpretation and other results that may emerge from the analysis. And thus my team had a couple of deliverables. The main ones were benchmark studies between different data science and BI platforms such as Dataiku and Sagi, data audit, data cleaning and clustering analysis with Python, R, and Dataiku, Power BI dashboards in real time to facilitate the interpretation of results and decision making by economic players, documentation that is imperative for each project in part, which was created by the entire team who worked on the proof of concept. Documentation such as analysis of the technical and functional architecture, data matching, clustering, interface contracts and technical architecture, anonymization capabilities, and progress report. There are, of course, some ups and downs that you will confront with along the way. Sometimes data science and machine learning are not the answer to everything, and sometimes, even if they are, managing projects in this area is not always easy and smooth. Prepare yourself for a lot of bumps on the ride because they will unfortunately arrive. The overall perception of companies is that hiring the best data scientists and machine learning engineers is sufficient to build great machine learning solutions. But if sufficient coaching and conditioning is not made, premature adoption of machine learning may affect outcomes in an economical, impactful manner. Organizations are eager to build data science teams for machine learning adoption, even if sometimes traditional BI might solve the problem faster and or better. Sometimes it is only required to go to the root of the problem, which is usually the quality of the data recorded and the quantity of it, which are crucial factors in having good results at the end. There is no need in having lots of data scientists for this, but just the company's eagerness to adopt standard methods and a good data manager. The aim of every project is thus to succeed and to fulfill its goal, to avoid failure at all costs. Well, not at all costs, because there are budget limitations that have to be taken into considerations. But to avoid failure at all costs once its business case has been approved. There are a lot of parties and many costs involved, and usually machine learning projects typically fail because no one understands what machine learning is. There's a failure to create, apply, and trust the project's processes. There's no measurement for success. There is a lack of firm support by key stakeholders. There is a lot of poor data quality involved. There's a lack of right data science team. There are a lot of complex models and overly complex models that are made without even having the need to do it. And there are a lot of over-promising results. I hope that this information is useful for you, and I know that you are going to work or you are already working on data science and machine learning projects, and this is why this presentation may help you to see the overall picture of projects in general and of data science projects and machine learning projects in particular. Some advices that may help you in your quest of working on machine learning projects would be to know the theory behind project characteristics and possible failures, understand the basic project management concepts, approach the data science project lifecycle phases, tools, and different roles, understand the workflow of a machine learning project from project ideation, organization around resources and tools, up to the project execution and implementation. These I consider are indispensable skills that you need to acquire, to practice and to master in order for you to be a great data scientist and not only an experienced developer that works in his corner by himself. Of course, it will be the case for you to work on different projects, but with effort and perseverance, communicating one's technical needs and sharing one's learning, and if the business circumstances are adequate, the project is bound to succeed with your help as well. There will be situations where you don't know if the direction of the project is the good one, and until you won't see the results, there will always be a bit of a doubt in the corner of your mind. Just keep in mind that your team will be there to help you and support you, and that with collaboration and a lot of communication, great inventions have been and will continue to be realized. So now I have reached at the end of this video. A last information that I would like to share with you is that good foundations lead to strong projects. And there will always be new challenges to overcome, dynamic projects that often come with a modified development process, a differing team archetype, etc. It is important for you to be able and to stay competitive in such a dynamic environment, which is data science, while understanding completely the business concepts that surround it. I wish you to have a very good week. Thank you.
Merci encore Andrea pour ce mini-cours. N'hésitez pas à nous dire ce que vous en avez pensé dans les commentaires. Vous allez pouvoir retrouver tout ce contenu et bien d'autres sur notre plateforme Julie. Le lien est juste en dessous dans la description. Donc en attendant le prochain épisode de Crack the Data, je vous souhaite une très bonne journée.